Greetings, I'm Dev the Developer. If you have not watched the lesson on general data types yet, it might be worth going back and watching that now. In this lesson, we're going to map those concepts to C#. The type names in C# are a little unusual in spots, so stay tuned for that. The easiest way to get into this is to just start writing. Let's go through the types we'll use day to day. First, booleans. In C#, we use the type bool. The two possible values are true and false, both lowercase. That trips people up occasionally if they're coming from a language that capitalizes them. We'll make more use of booleans in a few lessons when we start working with conditionals. For now though, just know they exist and how to declare one. In the last lesson, we talked about an unsigned 8-bit integer. In C#, that is just called a byte. It's worth noting, we don't have to declare and assign in the same line. We can split it into two steps. That's completely valid. Visual Studio will suggest you combine them, and usually you should. But there are times when you need to declare a variable before you know its value. Just know both forms exist. Now, byte is unsigned. If you need a signed 8-bit integer for something that can go negative, C# uses sbyte. The S prefix stands for signed. Sbyte ranges from -128 to 127. A coordinate on a small grid is a decent use case. Something that can be positive or negative, but never very large. Moving up in size, we come to 16-bit integers. In C#, the signed version is called a short. Short is signed. Ushort is unsigned. Port numbers are a classic use for a ushort. They're always positive and max out at 65,535, which is exactly the ceiling for an unsigned 16-bit integer. Now, you might have noticed the inconsistency I mentioned at the top. With byte types, the no prefix version was unsigned, and the S prefix meant signed. With short types, the no prefix version is signed, and the U prefix means unsigned. There's really no clean way to memorize it. You'll just have to know it after a few weeks. 4 bytes, that's 32-bit. This is the one you'll reach for most often. Int is signed and covers about positive and negative 2 billion. It's the default integer type and a good all-around choice for most whole numbers. Uint is the unsigned version. If you're tracking a quantity of something, inventory or count, unsigned makes sense because you'll never have a negative quantity. 8 bytes, 64-bit. That's when you need numbers that are too large for an int. Those underscores in the ulong value are a C# feature worth knowing about. They're ignored by the compiler, but they make large numbers readable at a glance. You can use them whenever you put a comma in written English. 1 billion is a lot easier to read with those separators than a wall of zeros. For decimal values, C# has two main options. Float is 32-bit. Double is 64-bit. The difference, as we previously covered, is precision. More bits means more decimal places. The F at the end of the float value is required. Without it, C# assumes you want to write a double. If you write 3.14 with no suffix, it's treated as a double by default. The F suffix is how you tell the compiler you specifically want a float. And finally, characters and strings. The clearest way to tell a char, or character from a string at a glance is the quotes. Char, or char, uses single quotes. String uses double quotes. A char is a single character. In C#, it's stored as a 16-bit value to support the full Unicode set. A string is a sequence of those characters. So far, we've been spelling out the type every time we declare a variable. C# lets you skip that with the var keyword. Let's look at a few examples. Var doesn't mean that it's loosely typed. C# is still a strongly typed language. It just means the compiler is figuring out the type for us based on what we assigned. Assigned a whole number and it picks an int. Assign a decimal with no suffix and it picks a double. Add the f and it picks a float. This is what's called type inference. Once the type is set at declaration, it's locked. You can't later assign a string value to count. The variable is an int and it stays an int. Var is useful when the type is obvious from the context or when the name is long. We'll see both of those cases come up as the course goes on. Everything we've declared so far has been a variable. The value can change. Let's take a deeper dive and see what that looks like. That works. It's a variable. We assigned it once, then changed it. But sometimes you don't want to declare a value that cannot be changed. For that, you use const. A constant is declared exactly like a variable, just with const in front. Once it's assigned, that value is permanent for the lifetime of that program. That won't compile. The compiler catches it before the program ever runs. A constant isn't a variable. It cannot be on the left side of an assignment. Constants are useful anytime you have a value that should never change. A tax rate or a max retry count or a fixed configuration value. Using const makes your intent clear and lets the compiler reinforce it. The type names in C# can feel like a lot at first, but there really aren't that many. Booleans, a handful of integer types at different sizes, floats and doubles, characters and strings. Most of what you will write day to day uses bool, int, double, and string, and occasionally char. The rest are there when you need them. We can also create our own types, and we will, but these are the ones built into the language, and they're the foundation everything else sits on. Practicing these types will make them easier to learn. Don't just watch it, do it.